Welcome. In today's lecture, we're going to study another test from biostatistic, and this is the Mann Whitney test, where this test is based on median and ranking of the data and developed by Mann and Whitney for unequal sample sizes. You are familiar with the ANOVA and the STQ test where we are using the equal sample sizes, and here a test statistic mu is used related to W. This test is non-parametric test and used in place of unpaired t-test. In this test, we can test the null hypothesis that two samples come from same population or not. Then this is the formula for the Mann Whitney test, where mu is the largest possible value of W and N1 for the size of sample from the first population and N2 from the second population, and W is the sum of rank in the largest sample. Now you can identify this with the help of example how this W or mu or N1 and N2 can be used. Here we have to assume that two samples are drawn randomly and identically from their respective population, and the test population do not differ except their medians. Okay, then for the solving of the example, we have to assume the two hypotheses. One is null hypothesis and another is alternate hypothesis. In null hypothesis, two population have equal mean, and in alternate hypothesis, population do not have equal medians. Okay, so here I have given either median of population X is smaller than Y, then HA hypothesis, and if median of population X is larger than median of population Y, then another hypothesis. Then computation, in which what we have to do for solving the example, we have to combine the ranks from the both samples and arrange them from the smallest to the largest, and these tied observations are assigned to rank equal to mean of the rank position. With the help of example, I am going to discuss with you how this can be used. So here decision rule is, first, if median of X population is smaller than Y, then sum of rank assigned to the X, and if it is smaller than sum of ranks assigned to the Y, then the observation from the Y population. Okay. Here one example is given that one group is under the treatment of placebo and another is under the drug, but it is important to note that from population of sample 1, that is X, the number of individuals, or that is N1, is different and N2 is different. Okay, so this test is used for unequal sample sizes. What they have asked in question, test the distribution of scores under placebo and under drug are identical. We have to calculate either it is identical or not. For that, what we have to do, from both the sample sizes we have to give them the ranks. Okay, and these ranks from the right from your 1 to the 16, as there are total 16 sample. And another step, that is we have to sum the ranks from the group 1 and group 2. Here the sum 1 from the first population is 41 and from second it is 95. Then the next step is score, either it is from X or Y. We have to rank right from 1 to 16 and assign them as X or Y. This table gives you as the digit 6, it comes from X population and it is ranked 1. Like that up to 16 we have given their ranking. Then directly putting the values in the formula. We know that N1 is 7, N2 is 9 and W sum of ranks in the sample first. But in this example, sum of rank is higher in the sample second. That's why we are using W as a 95. And by calculating or putting the value, we get mu is equal to 13. But we have to compare this mu with the tabular value where N1 is 7 and N2 is 9 and alpha is equal to not 5. And this is the table where we will get the N1 and N2. N1 is 6 and N2 is 7 and the value from this table is I think it is somewhat up to the 15. Okay, so again go back to the previous slide. What we have observed, since the critical value is less than calculated value, we get the calculated value mu, that is 13, and tabular value is 15. So it is less than the calculated value. That's why we have to reject this hypothesis. And this leads to the conclusion that distribution of scores under placebo and under drug are not identical. This is the table where we can use N1 and N2 at different significance levels for this samples. For the again S1 when X individuals are more than Y, and S2 is when Y individuals are more than X. In our example, sample Y is with more the sum of ranks of Y, thus S2 is taken because sum of ranks, number of samples in second population, that is Y is more, and rank sum is also more. That's why we have used W is equal to 95. So this is all about the Mann Whitney U test, which is used as a non-parametric test and for the unequal sample sizes. Thank you.